Like, the maps are on the test and you have to label features that we talked about in the readings, things like that. I mean, it's basically what purposes of the quiz, make sure you really do the readings. Okay? By the way, I think there's a few pages in here that are not that you were assigned. But in case you didn't know, I'm the world's stupidest person when it comes to using a photocopier. Anyway, all right, I think that's all the handouts there. Yes. All right, anybody have any questions about how the class is going to work? Yeah, it's a pretty straightforward class. All right. Okay. Well, I'm going to put this screen to black. Put the screen up, and we'll use the board for a while. We're talking about tropical meteorology. Hey, what time is it? I need to get logged. It's 10 to 11. We're in good shape. All right. Really good question to ask about the tropical meteorology course. Why is there a separate course? I mean, the atmosphere is just a gas, and it sits on top of the surface that gets warmed by the sun. What the hell difference does it? By the way, I sometimes swear like a sailor. I'm sorry. Hell was not so bad. What the hell difference does it make whether it's polar meteorology, tropical meteorology, mid-latitude meteorology? Why do we have a separate course for tropical meteorology? You know, so we don't have a polar meteorology class. We don't have a Midwestern meteorology class. And I'm going to tell you that there's going to be a whole lot of reasons why we need to have a separate course. And that's because the tropics are very different. There's a lot of differences in how the tropics work, or how we work with the meteorology of the tropics, than in mid-latitudes. And it justifies having a separate course about tropical meteorology. So I'm going to tell you that there's going to be lots of differences, and I'm going to sort these differences into 3 piles. One type of differences that we're going to have are the physical differences. Ways in which the tropics really are different. They're working in a different way than, say, the mid-latitudes. Another thing, another type of difference that we're going to talk about are what I'm going to call observational differences. We don't observe the tropics in the same way we observe the mid-latitude atmosphere. Well, in some ways we do, and in some ways we do differently. You know, the tropics have a lot of things going on that the mid-latitudes don't. It makes it hard to have like a surface station. You know, out here in Omaha, North Valley, and another one over here at the airport, there are weather stations. And it's kind of an obvious point, but they require things like ground. You have to have ground there, right? Most of the tropics is ocean. Okay? It's pretty hard to set up an AFOS weather station, you know, with its automated temperatures and stuff like that out in the middle of the ocean, right? You gotta have ground. And there's also going to be what we're going to call paradigm differences. We'll talk about this word paradigm a little bit later in the hour. It's easier to start with the physical differences. Ways in which the tropics are different than the mid-latitudes. Who wants to give me, just right off the top of their head, a way in which they think the tropics are different physically than the mid-latitudes?
Like land-wise? Or like
No, like as in, like, if you go there, how is it different? Okay. I'm thinking more general than that. The tropics in general. Warmer, right. Is it warmer everywhere? No, it's just warmer at the surface. Right? Because the source of heat is at the surface. In the real atmosphere, the heat, sun shines through the atmosphere, sun doesn't warm the air, ground warms the air, right? The ground in the tropics is very warm because it has high sun angles and whatnot. So it's warmer at the surface. It's actually colder aloft. The tropical tropopause is the coldest place in the atmosphere. You guys know what the tropopause is, right? The top of the troposphere. Okay? It's the coldest place in the atmosphere. Okay? So it's warmer at the surface and it's colder aloft. Hey, especially people who've had upper level classes like dynamics and stuff like that. what can you say about the atmosphere if it's cold, warmer at the bottom and colder at the top? What do we feel about like stability and stuff? Yeah, it's less stable, right? It's more likely that an air parcel near the surface can rise. Okay, let me write that down here for a second. It's less stable. That doesn't necessarily mean that there's thunderstorms all over the place in the tropics, although there certainly are a lot of thunderstorms in the tropics. In fact, why don't we put that down? Lots of thunderstorms in the tropics. But overall, the tropics are less stable because it's warmer at the surface and it's colder aloft. An air parcel near the surface is more likely to be warmer than the air around it and continue to rise than, say, the mid-latitudes. Certainly than the polar regions. All right. Let's see here. I always pick and choose as to which ones I really care about in a given semester. We did briefly mention that it is mostly ocean. You know, our planet is about 75% ocean, but the tropics is far higher than that. I'll bring up some maps of the tropics in a little bit, and you'll be able to say, oh wow, I never really thought about it. Except for Africa, that's in there is pretty small. And then you're back in the Atlantic, and then you got a piece of South America, and then you got the Pacific, which is like 14,000 kilometers across. And then you got a little bit of islands, and then you got the whole Indian Ocean. It's pretty much all ocean. What do we want to say about sun angles? Yeah, well, the sun angles are higher than in mid-latitudes. The length of day is also much more consistent. Now that has a huge meteorological impact, but you know the tropics at the equator, the length of day every day is 12 hours. Whereas at mid-latitudes, we go from having, you know, in Omaha, about a 15-hour day in the summer to like about a 9-hour day in the winter. Okay, I don't know that I can't think right now off the top of my head of any like meteorological phenomena that's hugely important to. But, how about the Coriolis force?
0.
Yeah, okay, this is always a tricky point. You know, the Coriolis force, the whole business, you know, the forces, air particles get deflected to the right in the northern hemisphere, left in the southern hemisphere. At the equator, it's 0. Yeah. Let's say it's at 0 at the equator, 0 at the equator, and it's weak in the tropics. There's some caveats here that we'll hit later in the semester. It's actually just the horizontal Coriolis force is 0. And weak doesn't mean not important. We're going to be all about the Coriolis force when we're talking about monsoon, things like that, for example. Doesn't mean that just because it's happening at 5 degrees north and we would say, oh, it's a weak Coriolis force. Well, it's still actually important. It's just weaker than the mid-latitudes. We have to think about it differently. By the way, the fact that the Coriolis force is 0 at the equator makes all kinds of interesting things possible at the equator that aren't possible at the latitudes. There's all kinds of waves in the atmosphere, types of troughs and ridges and types of motions in the atmosphere. They're only possible at the equator because they only work where there's no Coriolis force. So we're going to have all kinds of strange phenomena going on in the tropics, like El Nino or the Madden-Julian oscillation. These are terms you may or may not be familiar with, but you will. They're only possible where there's no Coriolis force, so they don't work at the equator. There are a couple other interesting physical differences in the tropics. One is that temperature and pressure gradients are weak. What's this word gradients mean? Yeah, differences over distance, right? Specifically, it's got to be over a distance. The temperature in Omaha is 84, the temperature in Lincoln is 86. There's a temperature gradient between Omaha and Lincoln. Okay? In the tropics, temperature gradients are relatively weak. That's a fancy way of saying there aren't fronts in the tropics. The temperatures are pretty consistent over large regions of the tropics. Similarly, pressure gradients. If you throw out things like hurricanes, where obviously there's a big pressure difference between the eye and the outside of the hurricane, in general, their pressure gradients in the tropics are weak. You don't find tropical weather systems by looking at maps of high and low pressure. That's how you would do it, right? If I sent you all down to look at the maps and said, what's going on in weather today, you go look at the surface map and you'd find the lows and you'd find the highs and you'd say, oh, this is what's going on, right? That's not going to work in the tropics because the highs and the lows aren't really all that big.
Are there any hurricanes that penetrate down